Hello and welcome to Science Night Tales. I am glad you found this quiet space to drift. Tonight, we are going to let go of the idea of near. We often think of space as a place full of stars and planets, but mostly it is just distance. Vast, quiet, unimaginable distance. We are going to travel outward, step by step, from the familiar orbit of the Moon to the edge of the observable universe. We will see how space opens up, how light takes time to travel, and how the universe is mostly made of room to breathe. You do not need to calculate anything tonight. You are safe to observe from a distance. You can simply let the scale wash over you. If this perspective helps you find calm in the vastness, you are welcome to like or subscribe. For now, let go of the ground and let's drift outward together. We're very good at understanding distance when it stays close to us. A few steps across a room, a short walk down a hallway, a street that takes 5 minutes to cross, a city that feels large but still familiar. Even when distance grows, it stays intuitive for a while. A drive that takes an hour, a flight that lasts a few more, a country, an ocean. Our minds are comfortable there. We evolved inside those scales. Our senses learned them. Our language fits them. But there's a point where that comfort quietly breaks. Not with drama, not with a sudden jump, just gently. Because beyond Earth, distance doesn't behave the way we expect. Most of the time, we don't notice this. We look up at the night sky and see stars scattered across it. They feel evenly spaced, close enough to count, close enough to connect with lines. But that picture is only a surface. It's a thin slice of something much larger. Something our intuition doesn't naturally follow. Out here, distance isn't measured by how far you could travel. It isn't measured by roads or routes or speed. It's measured by time, by how long light takes to cross empty space, and light is fast, faster than anything else we know. It circles Earth more than 7 times in a single second. It travels from the Sun to us in just over 8 minutes. Even that already stretches the idea of distance. 8 minutes, just to cross what feels like a nearby space. But that's still close, still familiar territory. Because once we step beyond that, the numbers stop fitting comfortably in the mind. We don't usually feel this because nothing around us forces us to. Gravity keeps us close. Air keeps us grounded. Life happens at the surface of one planet. So distance on a cosmic scale becomes something abstract. A fact we know but don't sense. Tonight, there's no need to rush into it. There's no destination to reach, no edge we're trying to arrive at. We're just letting our sense of scale loosen. Slowly. We can start where distance still makes sense, right where you are now. Think about the space your body occupies, the length of the room, the ceiling above you, the floor beneath you. These are distances your nervous system understands instantly. No calculation needed. Now widen that gently. The building, the street outside, the surrounding neighborhood. Nothing changes emotionally. It still feels manageable. Then the city, the region, the continent. At each step, distance grows. But the mind keeps up. Earth itself feels larger, but still contained. A sphere you can picture, an object you've seen in images your whole life. From space, Earth is just under 13,000 kilometers across, a number that sounds big, but still finite. Light crosses that distance in a fraction of a second. And already, something subtle happens here. Because even at the scale of a planet, light barely notices the distance at all. That's the first quiet clue. Distance out here isn't about effort, it's about time passing in empty space. And as soon as we move outward, Earth stops being the reference point. The moon feels far when you look up at it, but light reaches it in just over 1 second. 1 second. That's the gap between Earth and its closest companion. It looks dramatic in the sky, but in terms of distance, it's almost nothing. This pattern repeats. Our eyes and instincts exaggerate closeness. Space itself does not. Between Earth and the Sun, light takes 8 minutes. 8 minutes of uninterrupted travel through mostly empty space. Nothing to slow it down, nothing to mark the way, just distance. Already, that's farther than anything we can feel directly. And yet, in cosmic terms, this is still near the beginning. Because everything we've named so far exists inside a very small region, a neighborhood so tight that light crosses it in hours, not years. Our sense of distance keeps trying to hold on. It wants landmarks, it wants edges, but space doesn't provide many. Out there, separation is the default. Objects are not clustered tightly together. They are spread out, extremely spread out, and most of what exists between them is nothing at all. Not emptiness in a dramatic sense. Just absence. No sound, no resistance, no markers. Distance becomes smooth. And smooth distance is hard to feel. This is why cosmic scales rarely feel real. They don't announce themselves. They don't press against us. They simply exist. Quietly. So instead of trying to imagine everything at once, we let the idea unfold slowly. We don't jump, we drift from Earth outward, not moving fast, not accelerating. Just noticing how separation grows, step by step. Soon, the Sun becomes one object among many, then just a reference point. The distances between planets widen far more than we expect. The space between stars is wider still. And through all of it, one thing stays constant. Light keeps moving, second after second, year after year, crossing distances that have no texture, no scenery, no sense of scale from the inside. This is where intuition fades, not suddenly, just gradually. You don't lose it, you outgrow it. The way a map becomes less useful as you zoom farther and farther out. At some point, the details disappear. Only spacing remains. That's what this journey is really about. Not objects, not destinations. Spacing, how far things are from one another when nothing is filling the gap. When distance becomes the main feature, and the farther out we go, the more space itself takes center stage. There's no need to picture motion, no need to imagine speed. Distance doesn't require movement to exist. It's already there. Waiting. Measured not by steps or miles, but by how long light has been traveling before it reaches us. By the time it arrives, years may have passed. Thousands of years, millions. And nothing about that journey was dramatic. It was just long. This is the scale we rarely feel, because nothing in our daily lives prepares us for it. But once you notice it, you don't need to force understanding. You can just let the numbers soften into a sense of spacing, of quiet separation, of how much room there really is between everything. And as we continue, we won't rush. We'll stay close to where distance first begins to stretch, right at the edge of what still feels familiar. right where the solar system starts to open up, and intuition begins to gently let go. We begin close to where we already are, here on Earth. Not as a place to describe, but as a point to measure from. Because distance only starts to make sense when something stays still. From the surface of Earth, space doesn't begin suddenly. It opens gradually. A few hundred kilometers up, satellites move in steady paths, not far in cosmic terms, still close enough that light reaches them almost instantly. A single second of light is about 300,000 kilometers. That's enough to circle Earth more than 7 times. So even here, very near to home, light already moves faster than intuition expects. As we move outward, the first real gap appears: the Moon. On images, it looks close, sometimes large, sometimes almost reachable. But the average distance between Earth and the Moon is about 384,000 kilometers. Light takes just over 1 second to cross that space. 1 second of emptiness, nothing in between, no gradual fade, just open distance. When we speak to the Moon, the signal leaves Earth, travels that gap, and arrives a little more than a second later. If it returns, another second passes. A simple exchange already contains delay. This is still the neighborhood, still familiar, still close. And yet, even here, distance begins to show itself as time. From low Earth orbit to the Moon, the scale changes quietly, not with drama, just with numbers that grow. Beyond the Moon, there is no next object waiting nearby. There is only space that stretches before the next orbit appears. The region around Earth is mostly empty. Satellites occupy precise paths, but the volume around them remains vast and unused. Even in the busiest orbits, most of the space contains nothing at all. As we continue outward, the Moon's orbit becomes just one thin track around a much larger system. The Earth and Moon together circle the Sun. Now the distances expand again. The average distance from Earth to the Sun is about 150 million kilometers. Light takes just over 8 minutes to travel that span. 8 minutes of space. When sunlight touches Earth, it is already 8 minutes old. The Sun, as we experience it, is always slightly in the past. This delay doesn't feel dramatic. It feels normal. But it is the first time distance becomes unavoidable. If the Sun were to stop emitting light, Earth would continue to receive sunlight for 8 more minutes. Not because of persistence, but because of distance. Between Earth and the Sun, there are no markers, no halfway point that matters, just a continuous stretch of space measured only by travel time. As we move inward toward the Sun, we pass the orbit of Venus. As we move outward, we pass the orbit of Mars. These are not close neighbors. They are separated by tens of millions of kilometers. Light takes several minutes to cross from one orbit to the next. Still, the inner solar system feels compact in diagrams. Planets appear lined up. Distances look manageable, but the reality is quieter. Each orbit is surrounded by wide, mostly empty regions. Planets are points. Space is the dominant feature. The Moon fades behind us. Earth's orbit becomes a thin ring. Mars remains far ahead. Even here, within what we call the inner solar system, the scale is already larger than everyday experience can hold. Distances are no longer measured in steps or kilometers traveled by machines. They are measured in light minutes, and yet this is still the beginning. We haven't left familiar territory yet. We're still moving through space shaped by the sun's gravity, still within a region where distances, while large, remain countable. The reassurance comes from repetition, orbit after orbit, distance after distance. Nothing sudden. Space doesn't rush, it expands patiently. Light continues to move at the same speed everywhere. It never slows, it never accelerates, only the distances change. From Earth to the Moon, a little over 1 second. From Earth to the Sun, a little over 8 minutes. These numbers become reference points, anchors. They help the mind stay oriented as the scale continues to open. And even now, as space grows wider, the pattern remains calm. Objects stay where they are, orbits remain stable, distances repeat with steady precision. This part of the journey is about learning how space behaves, not as scenery, but as separation, not as motion, but as measured absence. As we continue outward, the gaps between paths grow wider. The time it takes light to travel grows longer, and soon the inner solar system will no longer feel compact at all. It will feel like what it truly is. A small cluster of points suspended inside a much larger quiet. The sun remains behind us, steady and distant. The inner solar system opens up, not with new objects, but with space between them. Mercury moves closest to the sun. Its orbit is small compared to what will come later. But even here, the gaps are already wide. Light takes a little over 3 minutes to travel from the Sun to Mercury when they are aligned. That distance is not filled with anything in particular. No gradual transition, just separation. From Mercury's orbit to Venus's orbit, the spacing grows again. Light needs several more minutes to cross that gap, depending on where each planet is along its path. Venus does not follow closely behind Mercury. Its orbit is its own ring, suspended farther out, with empty space all around it. When sunlight reaches Venus, it has already traveled about 6 minutes. That light continues outward, crossing more quiet distance before reaching Earth. Earth's orbit sits farther still. 8 light minutes from the Sun, another widening of space. Between Venus and Earth, there is no structure to mark the passage. No boundary, only increasing time. Signals sent between these planets do not move instantly. They take minutes to arrive. Even at light speed, distance makes itself known. Earth's orbit becomes one thin path among several. Not central, not special, just one location in a system defined mostly by space. As we move past Earth's path, Mars comes into view. Its orbit lies farther out, separated by a gap that feels noticeably larger. Light takes between 4 and 20 minutes to travel from Earth to Mars, depending on their positions. Sometimes closer, sometimes farther. The distance is not fixed. The emptiness between them expands and contracts with orbital motion. Still, the scale remains calm. There is no crowding here, no sense of closeness. The inner planets do not sit side by side. They occupy distant lanes, each surrounded by vast regions where nothing orbits at all. Even in the region humans tend to think of as nearby, most of the volume contains no planets, no moons, no landmarks, just distance. Light becomes the only reliable ruler. Minutes replace kilometers because kilometers stop helping. The numbers grow too large. Time becomes easier to feel. 3 minutes, 6 minutes, 8 minutes. More. These are not dramatic values. They don't demand attention. they simply accumulate. As we move outward, the inner solar system begins to feel less like a cluster and more like a sequence of isolated paths. Each orbit is precise. Each separation is quiet. Nothing rushes. Nothing crowds the space. The sun no longer feels close. The inner planets no longer feel grouped. They are spread out, suspended in a region that is already dominated by emptiness. And this is still early. We are still within the part of the solar system where distances are measured in minutes, not hours. The mind has time to adjust. Space has time to stretch. Ahead, the gaps will slow the journey further. Light will take longer, separation will widen. But for now, the inner planets fade gently behind us, leaving only the growing calm of space as the next region opens. The inner planets are already far behind us, not gone, just distant enough that they no longer shape how space feels. Ahead, the outer planets wait, spread across much larger intervals. Jupiter comes first. It does not arrive quickly. Light takes more than 40 minutes to travel from the Sun to its orbit. 40 minutes of steady motion. No landmarks, no interruptions. Between Mars and Jupiter, the solar system opens up in a way that is easy to miss at first. The space does not announce itself, it simply continues. As we move into this region, the sense of speed softens. Movement feels slower, even if it is not. Distance has begun to take control. Jupiter traces a wide path, far from the compact orbits of the inner planets. Its orbit feels isolated, suspended. Around it, there is no crowding, no sense of closeness, just a single path and a great deal of space. Beyond Jupiter, the gaps widen again. Saturn lies much farther out. Light now needs over an hour to reach it. An hour. That time is not filled with change. It passes evenly, quietly. Between Jupiter and Saturn, the emptiness stretches long enough to be felt. Not as drama, as calm. Saturn's orbit marks another distant loop. Separated from Jupiter by a span of space so wide that it resists quick understanding. Signals move slowly here. Information arrives late. The solar system begins to feel less like a collection of nearby paths and more like a sequence of distant positions. After Saturn, the spacing increases once more. Uranus waits far beyond. Light now takes more than 2.5 hours to arrive. Hours. At this distance, minutes no longer matter. Only duration does. The region between Saturn and Uranus is broad and uninterrupted. There is no sense of passing through stages, only continuation. Movement becomes less noticeable, not because it stops, but because distance overwhelms it. Uranus occupies a quiet orbit, alone in a vast interval. Its presence does not close the space around it. Beyond Uranus, the solar system stretches even thinner. Neptune lies still farther away. Light requires around 4 hours to reach its orbit. 4 hours of uninterrupted travel. At this scale, the outer planets no longer feel connected. They feel spaced apart by design, though no design is implied. Just separation. Each orbit exists on its own, each one distant from the next. The space between them is not empty in a dramatic sense. It is empty in a steady one. Nothing rushes, nothing pulls attention. The farther outward we move, the more motion fades into the background. Distance remains. Hours pass for light. For us, the journey continues at the same calm pace. The outer planets do not cluster. They do not gather. They mark points along a long, thinning structure. Past Neptune, even these markers become less reliable. The solar system's familiar layout begins to lose clarity. Ahead, the paths are no longer well-defined. Edges soften, boundaries begin to blur. What comes next is not another planet, but regions where distance itself becomes harder to measure by structure alone. Beyond Neptune, the solar system does not end. It simply becomes harder to define. The clear paths of planets are no longer there. The steady rhythm of orbits loosens. What follows is not a boundary, it is a region, a wide one. This is where the Kuiper belt begins. Not as a line, not as a wall, as a spread. Small icy bodies move here, each on its own distant path. They are separated by enormous gaps, so large that most of the space contains nothing at all. When we think of belts, we often imagine density, crowding, structure. This is different. The Kuiper belt is sparse, quiet. The objects are present, but the distances between them matter far more than the objects themselves. Some are only a few kilometers across, others are larger, many are irregular, but none of them define the space around them. Light travels for hours to reach this region from the sun, and then it keeps going. There is no sudden change in conditions, no signal that says we have arrived somewhere new, only continuation. The Kuiper belt stretches outward gradually, its inner edges estimated, its outer edges debated. Measurements vary, definitions shift, not because of confusion, but because the spacing makes precision difficult. Here, separation dominates everything. An object may pass millions of kilometers from another without interaction, without influence. The idea of a solar system edge begins to lose meaning. Instead of a final orbit, there is thinning. Instead of a border, there is dispersion. Some objects follow tilted paths. Some move far above or below the plane of the planets. Others drift on elongated routes that carry them far out and then back again. Patterns exist, but they are loose. The further we move into this region, the less helpful familiar categories become. Planet, orbit, distance, they still apply, but quietly. Light here no longer travels in minutes, it travels in hours. Time stretches evenly. Nothing accelerates. The Kuiper belt does not announce itself as important. It simply occupies a large volume of space. Most of that volume remains empty. Even where objects are present, they are isolated, each one separated from the next by distances that erase any sense of closeness. We pass through this region without passing anything in particular. There is no center to cross, no midpoint, just gradual outward movement. Some estimates place the Kuiper belt extending dozens of astronomical units beyond Neptune. Others suggest it blends into something even more diffuse. There is no firm agreement, and that uncertainty is part of its nature. Here, structure fades slowly, boundaries soften. The solar system begins to feel less like a system and more like a fading pattern. The Kuiper belt does not stop abruptly. It thins. Objects become rarer. Spacing increases again. Between one body and the next, there can be vast stretches of nothing measurable. The idea of distance shifts once more. We are no longer moving from point to point. We are moving through scale, and scale does not require markers. As we continue outward, the scattered objects become fewer, their influence weaker. Eventually, even this loose collection gives way to something quieter. Ahead lies a region where structure is almost completely absent, where distance exists with hardly any reference at all. And as we move toward that near total emptiness, the solar system fades further into the background. Past the scattered objects, the idea of a region becomes even looser. There is no visible change, no moment where something clearly begins. What follows is called the Oort Cloud, but that name can be misleading. It is not a cloud in the way we usually imagine one, not a layer, not a ring. It is a vast volume of space, extremely spread out, extremely quiet. The Oort Cloud is not defined by what it contains. It is defined by how far it extends. Objects here are separated by distances so large that encounters are rare. Some estimates suggest trillions of icy bodies, others suggest far fewer. Either way, the spacing remains dominant. Most of the region is empty. Light from the sun takes months to reach the inner parts of this area. Farther out, it takes years. A signal leaving Earth would not arrive quickly. It would move steadily, without landmarks. The Oort Cloud does not have a sharp inner edge. It does not have a clear outer boundary. It thins gradually, so gradually that measurements become uncertain. This is not a failure of observation. It is a reflection of scale. Here, distance outweighs structure. An individual object might orbit the sun once every millions of years. Its path is long, its motion slow. But motion is not the focus anymore. What matters is separation. Between one object and another, there may be a gap measured in light days, or light weeks, in some places light months. The sun is still present, its gravity still reaches here, but its influence weakens with distance, not abruptly, evenly. At these ranges, the solar system no longer feels compact. It feels extended, stretched thin. The idea of inside begins to lose clarity. There is no visible shell enclosing this region, no surface to cross, only a gradual transition from something sparse to something even more sparse. The Oort Cloud surrounds the solar system in all directions, above the plane of the planets, below it, far beyond it. It does not align neatly with the paths we are used to tracing. Orientation becomes less meaningful. Up and down dissolve into distance. Light continues outward at the same speed it always has, but the time it takes grows quietly. Minutes are no longer useful. Hours fade. Now we think in months, then years. A year of light travel is not a destination. It is a measure, a way to describe how much empty space lies between one reference point and the next. The farther we go, the fewer reference points remain. An object in the outer Oort Cloud might be so distant that nearby stars exert as much influence as the sun. Here, the solar system blends into its surroundings. Not suddenly, not dramatically, but gradually. The idea of belonging becomes unclear. Is this still part of the solar system, or is it something transitional? The question itself becomes less important than the scale it reveals. At these distances, definitions soften. What remains consistent is spacing, silence, time. There is very little to describe visually. No strong light, no dense clusters, just a slow extension outward. If we continued moving through this region, nothing would rush past us. Nothing would crowd the view. The sense of travel becomes almost abstract. Distance replaces movement. The Oort Cloud does not feel like a place we enter. It feels like a distance we acknowledge. And as we move farther still, even this diffuse region begins to fade. The sun becomes one influence among many. Its presence still measurable, but no longer dominant. Ahead lies a space where the solar system's reach finally loosens, where separation is measured not by months or years of light, but by the distances between stars themselves. And as we drift toward that wider emptiness, the idea of interstellar space begins to take shape. The transition happens without a clear moment. There is no line to cross, no signal that announces departure. The influence of the sun continues to weaken, slowly, evenly. And then, without anything changing in front of us, the solar system is no longer the main reference. What surrounds us now is interstellar space. This is not a region filled with stars. It is a region defined by the distance between them. The nearest star system lies more than 4 light-years away. That number sounds small when spoken quickly, but light takes 4 full years to cross that gap. 4 years of steady movement, without slowing, without stopping. Between one star and the next, there is no structure to guide the way, no repeating pattern, just separation. If we imagine a signal leaving the outer edge of the solar system, it would travel outward for years before reaching another star. During that time, almost nothing would change. No sudden increase in light, no gradual build-up, just empty space continuing. Interstellar space is not completely empty. There are traces of gas, thin dust, occasional particles, but these are spread so far apart that they rarely interact. On human scales, this would feel like nothing at all. On cosmic scales, this emptiness is normal. The stars we see at night feel close together because of perspective, because our eyes compress depth. But in reality, each star is isolated, separated by distances so large that even gravity takes time to travel between them. A star does not sit next to its neighbors. It occupies its own region of space. Around each one, there is far more emptiness than matter. As we continue outward, stars appear only occasionally. Long intervals pass with no visible change. Then, far ahead, a faint point of light. Another star, another system, another isolated island of mass in a vast surrounding volume. This pattern repeats, over and over. The Milky Way is often imagined as crowded, as dense, but that impression comes from images that compress scale. From this perspective, the galaxy is sparse, extremely sparse. The disk of the Milky Way spans about 100,000 light-years. Its thickness is much smaller. Within that disk, stars are distributed unevenly, grouped loosely into spiral arms. But even inside these arms, separation dominates. The Orion Arm is one of these regions. It contains our Sun and many other stars. Yet even here, the average distance between stars remains several light-years. There is no continuous chain, no close packing. The Orion Arm is not a solid structure. It is a statistical pattern, a region where stars are slightly more common than elsewhere. Between them, emptiness remains the rule. If we were to move across this arm, the experience would feel the same as before. Long stretches of nothing, occasional points of light, then more nothing. Motion loses meaning here. What matters is time. Light years become the natural unit, not because they are dramatic, but because they are accurate. A light year is simply how far light travels in 1 year. Nothing more, nothing less. When distances reach this scale, familiar measurements stop being useful. Miles and kilometers fade away, years replace them. Decades, centuries. Even at the speed of light, crossing the galaxy would take longer than human history. And yet, this is still a small part of the universe. The Milky Way is one galaxy among hundreds of billions, each one separated from the next by even larger gaps. But for now, we remain here, between stars, inside the galactic disk, where emptiness is not an exception, it is the default condition. Most of the volume of the galaxy contains no stars at all. Most of the space between them contains almost nothing. This is not a void created by destruction. It is simply how matter distributes itself on large scales. Sparse, uneven, separated. As we continue outward, the sense of direction softens. There is no longer a clear path to follow, only increasing distance, only expanding scale. The solar system is far behind us now, too small to matter. Ahead lies the broader structure of the galaxy itself, not as a collection of stars, but as a vast arrangement defined by the space between them. And as that larger pattern begins to come into view, our focus shifts again, from the distances between stars to the size and persistence of the galaxy that contains them all. The Milky Way does not announce its size all at once. There is no moment where it suddenly feels large. Instead, its scale becomes clear gradually, as smaller reference points fade away. Stars are no longer the focus. What begins to matter now is the space between them. The Milky Way spans roughly 100,000 light-years from edge to edge. That number is easy to say, but its meaning only appears when we slow down. A light-year is not a distance we walk across. It is time. It is how far light travels in one full year. So when we say 100,000 light-years, we are talking about 100,000 years of steady motion at the fastest speed anything can move. Not accelerating, not slowing, just constant travel. From one side of the galaxy to the other. The thickness of the Milky Way is much smaller than its width. Only a few thousand light-years from top to bottom. Even so, that thickness alone is larger than all of recorded human history, many times over. The galaxy is not a solid disk. It is a thin, uneven distribution of matter. Most of its volume is empty. Stars are spread throughout this disk with enormous gaps between them. Even when the galaxy looks bright in the night sky, that brightness comes from alignment, not density. Our view compresses distance. Reality does not. If we were to move across the galaxy, there would be no sense of crossing a crowded place. There would be long periods of nothing. Occasional stars passing at great distances, then more nothing. The Milky Way contains hundreds of billions of stars. That sounds dense. But when those stars are spread across a disk 100,000 light-years wide, each one becomes isolated. Distance dominates structure. Light-years begin to function less like measurements and more like a rhythm. They mark how long information takes to travel, how long a signal would need to cross from one region to another. When light leaves a star near the far edge of the galaxy, it travels for tens of thousands of years before reaching the opposite side. During that time, entire civilizations could rise and disappear. The galaxy does not notice. its processes continue at scales far larger than individual histories. From this perspective, the Milky Way is not something we look at. It is something we are inside, and being inside makes its size harder to feel until we step back far enough. The spiral arms are not tightly wound structures. They are loose patterns, regions where stars are slightly more common, but still widely spaced. Between arms, the separation grows even larger. There is no sharp boundary, no clear edge. The galaxy fades outward gradually. Stars become less frequent. Distances increase. Eventually, the galactic disk gives way to its outer halo, a sparse region where stars orbit far from the center. Even here, light years stretch easily between objects. The Milky Way's size is not dramatic because it is bright. It is quiet because it is vast. So vast that motion becomes almost irrelevant. Only duration remains meaningful. Light takes tens of thousands of years to cross the galaxy. Gravity takes the same amount of time to communicate change. Nothing happens quickly at this scale. Everything unfolds slowly, predictably, without urgency. The center of the Milky Way lies tens of thousands of light years away. It is not something we approach in this moment. It is simply a reference point. Another distant region defined more by separation than by activity. As we recognize the true size of the galaxy, something subtle happens. Our intuition adjusts, not fully, but enough. Stars stop feeling close. The Milky Way stops feeling like a background image. It becomes a structure measured in time, in long durations, in light traveling across emptiness. And once that adjustment settles, the next step feels natural. If the galaxy itself is this large, then moving across it will not bring us closer together. It will only reveal more distance, more separation. And so our attention begins to drift sideways, away from the center, across the wide, quiet disk of the Milky Way itself. Moving across the galactic disk does not feel like traveling through a crowded place. There is no sudden increase in activity, no sense of passing through regions packed with stars. Instead, the disk stretches outward quietly, wide, thin, and mostly empty. The spiral arms are often imagined as dense lanes of matter, but when we move across them slowly, that image softens. Stars do not sit shoulder to shoulder. They remain separated by large distances, often several light years apart. Even inside an arm, emptiness dominates. The arm is not a solid structure. It is a region where stars are slightly more common than elsewhere. Slightly. That difference only becomes meaningful when viewed across tens of thousands of light years. From within the disk, the change is subtle. As we move laterally, nothing dramatic happens. One star passes, then another, with long stretches of space in between. The disk is not a surface we cross quickly. It is a volume we remain inside for a very long time. Distances across the disk are measured in tens of thousands of light years. Light takes thousands of years to move from one spiral arm to the next. Signals move slowly. Change moves slowly. Nothing responds immediately. The stars themselves are not fixed points. They orbit the galactic center. But this motion is extremely gradual. One full orbit takes hundreds of millions of years. During that time, the galaxy's shape remains mostly the same. Spiral arms shift gently. Stars drift in and out of them. But from moment to moment, from year to year, From century to century, almost nothing appears to change. Motion exists, but it is stretched across time. When we think about crossing the disk, it helps to let go of the idea of travel as movement. Instead, it is better understood as duration, remaining in motion long enough for distance to accumulate. The disk is wide, but its thickness is small by comparison. Most stars remain close to the midplane. Above and below that plane, space opens quickly. Density drops, distances increase. The galaxy does not fill its own volume. It barely occupies it. As we continue across the disk, the spiral structure becomes less distinct. Arms blend into the background. Regions of slightly higher star density fade gradually. There is no clear line marking where one arm ends and another begins, only gradual change. This flattening of density is important. It removes the idea that larger structures must be more crowded. At galactic scales, size does not imply closeness. In fact, the opposite is often true. Larger structures exist because their components are far apart. Separation allows stability. Crowding would create constant disruption. Here, wide spacing allows slow, predictable motion. The disk feels calm because it is sparse, because nothing happens quickly, because distances absorb change. As we continue laterally, the sense of direction becomes less important. There is no clear destination within the disk, only more space, more time, more separation. Eventually, the disk begins to thin. Stars become less frequent. The spiral pattern loosens further. What remains is a broad region where motion continues, but interaction becomes rare. This is still the galaxy, still part of the Milky Way, but it feels quieter, less structured. The farther we move from the center, the more the galaxy resembles open space. Not empty, but close. At this point, it becomes easier to imagine leaving the disk entirely, not by crossing a boundary, but by continuing outward, letting distance increase, letting stars fall farther apart. The disk does not end abruptly, it simply fades, and as that fading continues, our attention begins to shift again, away from motion within the galaxy and toward what lies beyond it, toward the space that separates galaxies themselves. Beyond the outer regions of the galactic disk, the change is not sudden. There is no clear edge, no moment where the Milky Way simply stops. Stars become less frequent, then more widely spaced, until eventually the galaxy no longer fills the space around us. What remains is distance. This is where intergalactic space begins, not as a boundary, but as a continuation of separation. The nearest galaxies are not close in any everyday sense. They are grouped loosely in what is known as the local group, a small collection of galaxies bound gently by gravity. The Milky Way is one of them. So is Andromeda. So are dozens of smaller galaxies spread across a region several million light-years wide. Within this group, the distances are already immense. Light takes more than 2 million years to travel from the Milky Way to Andromeda. That time exists even between neighbors, between galaxies that are considered close, between systems that will not interact for billions of years. Intergalactic space is not filled with objects, it is filled with separation. Galaxies are points within a much larger volume. Most of that volume contains almost nothing at all. A few stray atoms, occasional particles, radiation passing quietly through. The dominant feature here is emptiness, not dramatic emptiness, just vastness without interruption. As we move farther from our own galaxy, the Milky Way becomes smaller. Not because it changes, but because distance accumulates. Spiral arms blur, individual stars disappear. The entire galaxy compresses into a faint shape, then into a small patch of light, and eventually into a single point. And still, we are only partway through the local group. The space between galaxies does not feel like travel. There is no sense of passing landmarks. There is only duration. Millions of years of light travel. Millions of years where nothing interrupts the path. This is the scale at which the universe becomes mostly space. Galaxies occupy a tiny fraction of the available volume. Even groups like this one are sparse. Gravity holds them together, but gently. Interactions are slow. Collisions are rare. Change unfolds over enormous timescales. The local group itself is quiet. Galaxies move slowly within it. Their paths are measured in hundreds of thousands of years. Their interactions stretch across billions. Nothing rushes. Nothing reacts quickly. The farther we move from the Milky Way, the more uniform space becomes. Direction matters less. Position matters less. Distance becomes the only meaningful measurement. Millions of light years. Then more. At this scale, and the idea of isolation takes on a different meaning. Each galaxy is surrounded by enormous empty regions. The separation is not accidental. It is the natural outcome of expansion and gravity balancing over time. Matter gathers where it can and leaves vast gaps where it cannot. Intergalactic space is not empty because something was removed. It is empty because most of the universe never condensed. This perspective changes how size is understood. Galaxies are large, but the space between them is larger. Groups exist, but they are loose. Everything is defined by what lies between. As we continue outward, the local group no longer feels central. It becomes one small arrangement among many. A modest collection of galaxies floating in a much larger field of space. At this point, the idea of clustering begins to emerge. Not density, but pattern. Galaxies do not appear randomly. They gather into groups, then into larger associations. But even these patterns are defined by separation, by the vast regions that remain untouched between them. And so, as the space between galaxies stretches wider, attention begins to shift again. From individual galaxies to how galaxies relate to one another. From isolation to loose connection, toward the next level of scale, where distance still dominates, but structure begins to reappear. As distance continues to widen, structure does not disappear. It simply changes form. Beyond individual galaxies, patterns begin to show up again, not as tight clusters, but as loose associations spread across enormous space. These are galaxy groups. They are not crowded. They are not compact. They are arrangements defined more by gravity than by proximity. A galaxy group can span millions of light years. Within that space, galaxies remain far apart. The distances between them are still vast. Light still takes millions of years to cross from one to another. And yet, they move together. Not quickly, not visibly, but consistently. Gravity is the only reason these groups exist, not as a force that pulls everything close, but but as a quiet influence that keeps motions related over time.
To listen to.
Galaxies in a group do not orbit each other the way planets orbit a star. Their paths are broader, slower, more subtle. Each galaxy follows a long trajectory through space, slightly shaped by the combined mass of the others. This influence is weak at any given moment, but it never stops. Over billions of years, it adds up. That is enough to define a group. From this scale, density still does not return. Most of the space inside a galaxy group is empty. The galaxies occupy only a small fraction of the total volume. Between them are stretches of intergalactic space, largely unchanged, quiet, thin. Even where gravity connects them, separation remains dominant. Groups do not feel like gatherings, they feel like alignment, a shared motion across distance. Some groups contain only a few large galaxies, others include dozens of smaller ones, but none of them feel crowded. The idea of nearby no longer applies. Here, closeness is measured in millions of light years, and that becomes normal. From this perspective, the Milky Way's local group is unremarkable. It is one small example among many. Scattered across space, there are countless similar groupings, each one defined by the same balance: gravity holding, distance prevailing. As we move outward, individual galaxies become harder to distinguish. Groups become the unit of scale, not because they are dense, but because they are coherent over time. They move together through the universe's expansion. Their internal motions remain related even as everything slowly drifts apart. This balance is important. Without gravity, galaxies would separate completely. Without expansion, they would collapse inward. What we see instead is persistence, structures that remain recognizable, not because they resist change, but because change unfolds slowly. At this level, motion is measured in hundreds of millions of years. No sharp turns, no sudden interactions, only gradual shifts in position, gradual changes in spacing. The groups themselves are not permanent. Over very long timescales, they can merge, they can disperse, they can be reshaped by larger gravitational fields, but those changes are so slow they barely register in the present. Right now, they appear stable, not fixed, but enduring. As scale increases, expectation shifts. It becomes tempting to imagine that larger structures mean greater density. But the opposite is true. The larger the structure, the more space it contains. Groups are larger than galaxies and emptier. Their defining feature is not what fills them, but what connects them. Gravity stretches across immense distances. It does not need closeness to operate. It only needs mass and time is abundant. From this viewpoint, the universe looks ordered without being crowded, organized without being compact. Patterns emerge, but they remain light, open, spread thin across space. As attention continues to pull back, these groups no longer feel distinct. They begin to blend into a larger pattern. Groups relate to other groups, associations extend outward, and the scale expands again towards structures that are even larger and even more defined by distance than by matter. At this scale, organization increases again, not by becoming tighter, but by becoming broader. Galaxy clusters are among the largest clearly defined structures in the universe. They contain hundreds, sometimes thousands of galaxies. From a distance, that sounds dense. From within, it is anything but. A galaxy cluster can span tens of millions of light years. Some extend even farther. Within that space, galaxies remain separated by vast distances. Millions of light years still lie between neighbors. Light still takes enormous time to travel from one to the next. What changes here is not closeness, it is reach. Gravity, once again, is the only unifying factor. In a cluster, the combined mass of many galaxies creates a deeper gravitational field. This field does not pull everything together into one place. Instead, it slows their separation. It bends their paths just enough to keep them associated. Galaxies within a cluster move through space along long, slow arcs. Their velocities are measured in hundreds or thousands of kilometers per second. Yet over these distances, that motion remains gentle. Nothing rushes, nothing collides frequently. Most galaxies will never come close to another. Even in clusters, empty space dominates. Between galaxies lies a thin medium of hot gas. Between that gas, even more emptiness. Matter is present, but it is spread out, diluted across an enormous volume. From this perspective, a cluster is not a crowd. It is a region, a gravitational basin where paths overlap over time. Beyond individual clusters, scale expands again. Clusters themselves are separated by tens to hundreds of millions of light years. Between them are voids, regions with very few galaxies at all. These voids are not small gaps. They can be hundreds of millions of light years across. They make up most of the universe's volume. Clusters and voids together create a large-scale pattern, a loose, web-like arrangement. Not a solid structure, but a network defined by distance. Superclusters emerge from this pattern. They are not tightly bound objects. They are associations of clusters linked by gravity and shared motion, but not compact. A supercluster can span hundreds of millions of light years. Some stretch toward a billion. Within that span, clusters remain far apart. The spaces between them are vast. Expansion continues everywhere. Gravity only slightly reshapes the flow. Superclusters are not permanent. Unlike galaxies or clusters, they are not fully bound. Over time, cosmic expansion will pull them apart. What we observe now is a temporary alignment, a moment where gravity has slowed separation but not stopped it. Even at the largest visible scales, the universe resists becoming dense. Structure never overcomes distance, it only traces it. What matters is not how much matter exists, but how it is distributed. And distribution favors emptiness. As scale increases, detail fades. Individual galaxies disappear from awareness. Clusters become points. Superclusters become regions. What remains consistent is separation. The universe does not build upward by filling space. It builds by organizing motion across it. Distances grow faster than structures. Time becomes the dominant unit of measurement. Tens of millions of years, hundreds of millions, billions. Light years are no longer just lengths, they are durations. Travel becomes impractical to imagine. Movement becomes abstract. At this point, perspective settles. There is no expectation of a dramatic reveal, no hidden density waiting at the top. The pattern is already clear. Larger scales mean greater emptiness, greater calm, greater separation. Yet coherence persists, not as solidity, but as relationship. clusters relate to clusters. Superclusters trace gentle shapes across space. Void regions dominate the volume between them. Nothing fills the gaps. Nothing needs to. This is not absence. It is the default condition. Matter is the exception. Structure is the variation. Distance is the rule. As attention pulls farther back, even superclusters begin to lose their identity. Their edges blur, their boundaries dissolve. They transition into something broader, less defined, closer to the limits of what can be observed. From here, the idea of structure itself begins to thin. What remains is scale, and the quiet realization that even the largest things we can name are still mostly space. At the widest scale we can meaningfully describe, distance stops behaving like space at all. It becomes time. The observable universe is not defined by a wall or an edge. It is defined by how long light has been able to travel, roughly 13.8 billion years. That number does not describe size in the ordinary sense. It describes duration. Every point we observe, every galaxy, every faint background glow is seen not as it is now, but as it was when its light began moving toward us. The farther away something is, the older the light becomes. At great distances, we are not looking across space. We are looking back through time. Because the universe has been expanding while that light traveled, the observable universe today spans much farther than 13.8 billion light-years. Its current diameter is closer to 93 billion light-years. Not because anything moved faster than light, but because space itself stretched in the meantime. This boundary is not a physical surface. There is no sudden transition. No final structure, no thinning curtain. It is simply the limit of information. Beyond this distance, light has not had enough time to reach us. Not yet, and perhaps never. What lies beyond the observable universe is not known, not measured, not confirmed. It is not correct to imagine it as empty, or full, or similar. Those are assumptions carried outward beyond their validity. All that can be said is that it exists beyond our horizon of evidence. The term observable is crucial. It does not describe the universe as a whole. It describes the portion of it that can causally affect us. A sphere centered on here. But here could be anywhere. Every observer, anywhere in the universe, has their own observable boundary. Each one centered on their position. Each one limited by time. There is no privileged center, only local perspectives. As expansion continues, this boundary slowly changes. Some distant galaxies we see today will eventually fade. Their light will stretch longer and weaker. Eventually, it will never reach us again. Not because they disappear, but because the space between us grows too quickly. The observable universe is dynamic. Its contents shift, its limits evolve. Yet, at any moment, it remains incomplete, always partial, always finite in reach. At this scale, familiar intuitions no longer apply. There is no meaningful direction outward, no place to arrive, no frame in which the whole can be viewed at once. Language itself becomes approximate. We speak of edges, but there is nothing edge-like there. We speak of beyond, but there is no boundary to cross, only a gradual loss of access. What remains constant is the pattern seen at every previous scale. Distance dominates, Separation increases, structure never fills the available volume. Even if the universe extends infinitely beyond what we can observe, it does so quietly, without crowding, without urgency. If it is finite, its size exceeds any direct description. If it is infinite, infinity expresses itself as more of the same. More space, more separation, more time. Neither option produces a dramatic conclusion. Both dissolve expectation. At the observable boundary, questions do not end. They soften. Certainty thins. Precision gives way to acceptance. This is not a failure of understanding. It is a natural limit imposed by time. The universe does not hide its edge. It simply has not finished speaking to us. Light from beyond the horizon may still be traveling, or it may never arrive. Both are equally calm possibilities. From this perspective, significance shifts again, not toward importance, but toward placement. We exist inside a small moving window of information, a region defined by patience rather than reach. Everything we know about the universe fits inside that window, and yet that window is vast beyond ordinary comprehension. Billions of galaxies, trillions of stars, all contained within what time has allowed us to see. The realization does not demand awe, it does not demand reflection, it does not ask for response, it simply rests. Scale has expanded as far as it can without breaking meaning. Beyond this point, narration no longer needs to continue outward. Distance has already done its work. Perspective no longer sharpens, it loosens. The universe does not end here. Only the story available to us does. And even that story remains unfinished, still arriving, still spreading, still quietly incomplete. Distance does not end when explanation ends. It simply keeps going without asking to be followed. After everything we can measure, after every scale we can name, distance remains. Not as a destination, not as a mystery to solve, just as a condition. Light continues to travel. Some of it has been moving since long before Earth existed. Some of it began its journey before the first stars formed here. Some of it will never arrive. Not because it is blocked, but because time itself becomes too large. In space, distance is not felt as length, it is felt as waiting. Seconds, minutes, hours, years, millions of years. At each step outward, motion slowed, not because anything resisted it, but because scale replaced speed. Objects mattered less, gaps mattered more. The farther we moved, the quieter the structure became. Planets separated by minutes of light, stars separated by years, galaxies separated by millions of years. At no point did space fill in, it only opened. This is the pattern that does not change. No matter how far out we go, space is mostly space. Matter appears briefly, then distance resumes. Even the largest structures we know are thin patterns spread across emptiness. Clusters are separated, superclusters are separated. Everything meaningful exists because distance allows it to remain distinct. Without separation, nothing holds form. Distance is not absence, it is spacing. It is the reason things do not collapse into one point. It is the reason motion has room to occur. It is the reason light needs time. From here, there is no further outward movement required. The scale has already exceeded intuition. What remains is not expansion, but settling. Awareness slows. Thoughts no longer try to connect everything. They rest inside what is already known. that the universe is not crowded, that it is not rushed, that it is not arranged for attention. Most of it is quiet. Most of it is far apart. Most of it exists beyond any moment of observation. This does not make our position smaller in a dramatic way. It makes it lighter. There is no demand to grasp the whole, no expectation to reach an edge, only a gentle understanding that existence takes place inside distance, and distance does not need an audience. Even now, light is crossing regions we will never name, passing through emptiness that will never be charted, carrying information that will never be received. That does not make the journey meaningless. It simply means not all motion ends in arrival. The universe does not rush toward conclusions. It continues at its own pace. Stars orbit slowly. Galaxies drift patiently. Expansion proceeds without urgency, and within all of that, there is room to be still. Nothing about scale asks for response. It does not require wonder. It does not require fear. It does not require interpretation. It exists whether it is noticed or not, and yet, knowing it changes something subtle. Not how we act, not what we do next, just how heavy things feel. Problems shrink not because they disappear, but because they are no longer surrounded by pressure. Thoughts slow because they no longer need to arrive anywhere. There is no finish line at the edge of space, only continued separation, continued time, continued quiet. Even the concept of here becomes soft. Here is simply where information has arrived. Everywhere else is still on its way or never coming. That is enough. Nothing more needs to be added. The universe is not asking to be understood all at once. It allows partial knowing. It allows incomplete views. It allows rest. Distance does not compete for attention. It does not announce itself. It simply remains. Between stars, between galaxies, between moments. The same separation that keeps things apart also gives them space to exist. And in that space, nothing is required. No conclusion forms, no summary closes. Scale does not resolve into meaning. It gently removes the need for one. What remains is a sense of placement, not central, not peripheral, just present. Inside a vast expanding quiet that continues whether it is named or not. Light keeps traveling, space keeps stretching, distance keeps being distance, and there is no urgency to follow it further. Everything essential has already been said, and even that can fade. The universe does not end, the explanation does. What continues beyond this point does not need words. It only needs time, and there is plenty of that. Enough for light to keep moving, enough for space to keep opening, enough for stillness to remain uninterrupted. And so the scale holds, unresolved, unfinished, unbothered. Distance remains,